Hello and welcome to Ashford.com. You are watching an interesting video on sound waves offer a way to sort cells without having to expose them to chemicals or damaging forces. Please read this disclaimer carefully. A tool that can test a cancer patient's blood for rare tumor cells is extremely useful for checking if a tumor is going to spread. Now scientists have found a way to do this using tilted sound waves in a device no bigger than a small coin, offering an effective way of sorting cells without having to treat them with chemicals or deform them mechanically. The team includes members from MIT, Cambridge, MA, Pennsylvania State University, University Park, PA, and Carnegie Mellon University, Pittsburgh, PA, and reports its findings in the Proceedings of the National Academy of Sciences. Sound waves offer a way to sort cells without having to expose them to chemicals or damaging forces, as co-senior author of the new study, Dr. Ming Dao, a principal research scientist in MIT's Department of Materials Science and Engineering, explains. Acoustic pressure is very mild and much smaller in terms of forces and disturbance to the cell. This is a most gentle way to separate cells, and there's no artificial labeling necessary. Tilted sound waves separate cell types more effectively. Theirs is not the first attempt to separate cells and small particles using sound waves. If you take a mixture of cells or particles and make them flow in one direction, you can deflect their travel very slightly by exposing them to sound waves. The amount of deflection depends on the cell's physical properties like size and compressibility. But previous efforts to make cell separators work using sound waves have not been able to make the difference in deflection big enough to separate the cells effectively. Dr. Ming and colleagues solved the problem by using tilted sound waves. These cross the cell's trajectory at an angle instead of going straight across, ensuring that each cell encounters several low-pressure nodes on its journey through the microcanal instead of just one. Dr. Ming and colleagues solved the problem by using tilted sound waves. These cross the cell's trajectory at an angle instead of going straight across, ensuring that each cell encounters several low-pressure nodes on its journey through the microcanal instead of just one. In their study, the team first tested their device using plastic beads and showed it could separate beads of 9.9 microns from beads of 7.3 microns in diameter with around 97% accuracy. A micron is 1,000th of a millimeter. They further developed the device by adding a computer simulation module that can predict the trajectory of a particle through the microcanal based on its size, compressibility and density and the angle of the sound waves. This feature means the device can be customized to sort different types of particle or cell. 71% of tumor cells recovered in a lab mix of breast cancer and white blood cells. The team also tested how well the device was able to separate MCF7 breast cancer cells, 20 microns diameter, from white blood cells, 12 microns in diameter. The cells also differ by compressibility and density. The results showed the cell sorter recovered around 71% of the cancer cells. The team now plans to test the device with blood samples from cancer patients in clinical settings. Circulating tumor cells are very rare. 1 milliliter of a typical cancer patient's blood may only contain a few tumor cells. The researchers have filed for a patent on their device. They see it helping clinicians determine whether a patient's tumor is about to spread to other sites of the body. When tumors are readying to do this, they begin to send out cells that travel through the bloodstream. The National Institutes of Health and the National Science Foundation helped fund the study. Meanwhile, engineers at Princeton University, NJ, are working on a way to use laser technology to measure blood glucose non-invasively. They hope one day their innovative diagnostic method will help diabetics do away with pinpricks for testing blood sugar. Notes and references. Thank you for watching this interesting video. This channel offers motivational, inspirational, valuable and informative videos to soothe, cleanse and inspire your health, mind, body and spirit. Subscribe this channel, to find lot of interesting videos on wide range of topics here. Stay tuned and keep watching.